Okay, what we're doing today is we are looking at simplifying and evaluating algebraic expressions. So what we're going to be dealing with is algebraic expressions, and we're going to be doing two things, simplifying and evaluating. What does the word simplify mean normally? What do you think of when you hear simplify? Make things smaller. Okay, smaller, simpler, easier is what I kind of think. Make it easier, smaller, or more put together than it was before. And evaluate. What words kind of embedded in the word evaluate? Alex? Yeah. So I want to find the value of these expressions. Do you guys remember our basketball example with who are Gia and Anna and Mary? Do you guys remember that example? And do you remember how we didn't get any numbers other than Lois was 5 more than Rose, and then this girl was 7 less, but we didn't actually get the actual values, right? What we're going to do when we evaluate is we're going to find the values of these expressions. So first we're going to talk about simplifying, then evaluating. But before all of that, we're going to talk about the word term. Okay, a term is a number, a variable, or a product of a number and one or more variables. Now that sounds like a lot, but I'm going to break it down into 3 parts. A term can be a number. A term can be a variable. Or a term can be a product, or the product of a, I'll underline this, a number and one or more variables. Now that third part is like, what? Let's just look at the most basic one. How many years have you been dealing with terms? What do you think? Look at the definition and think, all right, how many years have I been dealing with terms? How long have you been in school is what I'm asking you. Yeah, the first day, and really before school for a lot of you, when you learned the number 1, do you know that the number 1 is a term? How do I know that? What's the definition of a term? It could be a number. And then maybe in the last few years you've dealt with numbers that are negative, but that's also a term. Negative 10 is also a term. These are examples so far. Okay? More recently, maybe last 1 or 2 years, you've dealt with variables. So can you give me an example of a variable? A. That's also a term. How do I know it's a term? Because a term could be a number or a variable. So it is a variable right there. And you can also have negative versions of that. Negative G. That's a variable and it's negative. Okay. Now, the last one says product. Do you guys remember our keywords? Yeah, product refers to multiplication. So the multiplication of a number and one or more variables. That's an example of a product of a number and one variable. So what's going on between these two, 7 and m? They're being multiplied. So is that a term? According to our definition, it is. And here's a tough one right here. Is that a term? According to our definition, is it a product? That means, are these all just being multiplied? Yes. Do we have a number? 1/2. Do we have one or more variables? Yeah, we have how many variables? 3. And this one's to the second power and that one's to the third power. So we do have a lot of variables, but that's still a term. Do you understand what a term is? Do you understand that we've been dealing with terms for a long time? We're just going to call them terms from here on out. In fact, in Algebra 1, I'm going to refer to terms a lot. I'm going to say, what's the second term? Second term? I don't even know what a term is. So if you understand what a term is, you can at least give me that second term. Okay, let's look at this term right here. 2a. Sam, what's going on between 2 and a?
Being multiplied.
Being multiplied. What's being multiplied, Hagen?
2 and a.
2 and a. Okay, this is one term. It has many parts. The first thing I want you guys to get is what we call the numerical. Have we seen that word before? Yes. The numerical, this may be new, coefficient. Numerical coefficient. You're like, coefficient? I get numerical. What's coefficient? Does anyone know what the prefix co usually deals with? Cooperation. Sorry, together. Yeah, co means together. You have this number working together with what?
A variable.
A variable, which is called a literal coefficient. Literal. Where'd they get that word from? How do they get literal? Okay, literacy, which deals with what? Letters and words and sentences. But yeah, it's just a letter. Literal coefficient. What are these two things doing together? They're being multiplied. So they're working together. That's why we call them coefficients. They work together. Okay. Do you guys get the difference between numerical and literal? Numerical is dealing with what? Numbers. And literal is dealing with variables or letters. Good. Okay, but sometimes Mr. A is going to do this. He's not going to say numerical coefficient. He's not going to say literal coefficient. He's just going to say coefficient. When I just use the word coefficient, which one am I referring to? Which one am I referring to? What do you got? It's a 50-50 guess. Gracie?
Them working together.
Okay, they are working together, but I'm referring to one of these when I just use the word coefficient. Just take a guess. What do you think? Numerical, that is correct. If I just say, what's a coefficient? What are you thinking of? Numerical coefficient, which in this case would be 2. Good. You guys get that? All right, so far we're just getting some new terms put in, with the first one being term. And then we're getting these other coefficient words and all that. Okay, time to move on. Not all terms have numerical and literal coefficients. Okay, look at this term right here. This is 3. What is the numerical coefficient? 3. What is the literal coefficient? It doesn't have one. So we give this a special name. When there is no literal part, we call it a constant. It's a constant. Do you know why we would call it a constant? Why would we call it a constant? What does that mean? It doesn't change. It doesn't change. 3 is 3. When you add it with another number like 10, the number 13 is still with the number 3 and 10. It's still part of it. It's a constant. What do you call a letter? What's another name for a letter in math? A variable. Why do you think we call it a variable? Because it can change. That's how we get these two words. Okay, let's see if you guys are paying attention. Jackson, what is the numerical coefficient? 3. All right, Brad, what is or are the literal coefficients?
W and X.
W and X. We accounted for all of them. Drew, what's the coefficient?
3.
How did he know it was 3? How do you know I'm not talking about W and X?
This is a number and this numerical.
Yeah, when I say coefficient, which one do I want? The number. Okay, good. You guys got it. Any questions so far? Pretty straightforward, I think. Okay, good. Uh-oh. Write this expression down right here, and then write this definition. This will be the last big definition. We talked about terms. Now we're going to talk about not just terms, but like terms. Yes, ma'am?
Is that 20 or 20?
Right here?
Yes.
20. Yeah, that's okay. You can ask that. And when we use variables, we tend to use a lowercase. So just to help you out, it would have been like that. Which, notice, is O a good variable to use? Not usually, because it gets confused with a 0 a lot. What's another variable that's not so good to use? L is not a great one. Anyone else?
I guess X, like, it could be like the multiplication sign.
Okay, X, you got to be careful because if you're like this, if you're sloppy, what does that look like? 2 times. What? 2 times what? No, I didn't mean that. Good. That's another one. What's another one that might not be that great?
T.
T is not because it looks like a plus sign. Anyone else? S? Is that a good one? Oh, S is good. Could look like a 5. Any others that might be a trouble? Okay, the ones that are hard to use are the ones you don't write properly. So if you're sloppy in your writing, most variables are bad for you to use. If you're neater in your writing, even an S or a T or, dare I say it, an L can be used properly. So just be careful with your handwriting because it does mess you up. Okay, everyone have this down? Okay, if you don't have it down, keep writing it, but let me go through this. Looking at this expression right here, how many terms are up there? How many terms? Plural. It's not one term. It's an expression, but it has many terms. How many? Show me with your fingers. You can say this many, that many, that many. You know, whatever you want to show. Okay, sorry. Let me look here. Okay. Most of you have it. I have 1, 2, 3, 4, 5 terms. 5 terms. How many of you got that? How many of you were doing this? Okay, good. 5 terms is the answer. Do you notice what separated these terms here? What separates the terms usually? Addition. In fact, I'm going to tell you right now, addition does separate these terms. So I have 2a, 3c, 1a, 2c, and 20. Okay, 5 terms. Great. What is the coefficient, Matthew, of this term? 2. I said, what's the coefficient? It's the number. Eva, what's the literal coefficient? C. Sam, what's the coefficient?
1.
1. Gracie, what's the numerical coefficient? 2. Mary, what's the coefficient? 20. What's the literal coefficient? Josiah? There isn't one, so this is called a special term. It's called a Alex. Constant. This one has no variable, so it's a constant. Good. It doesn't change. This can change, that can change, but not that 20. Okay, good. Yes, sir?
Where's the W?
W. Oh, yes, sorry. Yep, with. When you see a W with that little / think with, the word with. Sorry, that's slang for writing. All right. What's a like term according to that definition? Terms that have the same with the same. They have to have the same variables, and those variables have to have the same exponents. That's like critical, key, crucial to your understanding of terms and how to make it simple. What's our first goal in this lesson? What does it say in the title? To do this and this? Simplify, right? My first step is to understand what like terms are. Okay. According to this definition, terms that have the same variables, same exponents, which terms are the same? Or which terms are like terms, I should say. Like terms. Like terms. 2 people know, 3 people know, 4, 5, 6, 7, 8, 9. Good, I see that hand. Jack.
2A and L.
Say that again?
2A and 1A.
1A, good. Yeah, and if I do an L, I'll put a cursive L because that'll make it clear for you guys. All right, 2A and 1A. So I'm going to circle those right now. I'll circle those 2 right there. Okay. Are there any other like terms? Yes, Michelle.
3C and 2C.
3C and 2C. Now notice, how did I mark those up? I circled 2 like terms and I boxed 2 other like terms. Why do I do that?
Show which ones are.
Yeah, these 2 are like and those 2 are like. They are not all together like. Okay, how do I know that the 2 circled terms are like terms? How do I know that?
Because they're both same. They both have the same literal. How do you say?
Or they both have the same variable
Yeah.
with the same. Wait, exponent? Is that what I put?
Yeah. I mean, same. Yeah.
All right, we haven't talked about exponents today other than me writing it here. What's the exponent of A? There's a 1 there. It doesn't have to be written there, but it is there. What's the exponent of A here? Okay, do these 2 terms have the same variable? Yes. Do those variables have the same exponents? Yes. Even though they're not written, they are the same. Okay, what about 3C and 2C? Someone explain why they're like terms. Darius.
Because they have the same exponent.
They have the same
Variable.
with the same Good. And does that matter the way I'm saying that? Because you can have both having an exponent of 2, but they don't have the same variable, so they're not like. They have to have both. Okay. What we're going to do with this. What are we going to do here? Okay, I'm going to rewrite it for my sake because I don't have it. I don't have enough room. Was it 2a plus 3c plus 1a plus 2c plus 20? Okay, I'm just rewriting it so I can show you my work. Okay, if these two are like terms and these two are like terms, why did I mark them differently? I'm just showing them. You see, I'm giving you different ways of marking them, so you use your way, whatever it takes to figure it out. Okay, I'm going to do this, and someone tell me what I'm doing here. Don't say it out loud, just wait. Someone tell me what I did. Which property did I use? Hudson? Commutative property of? What operation? Yes. Addition, yep. Were these being added? Were these being added? These being added? Everything's being added, right? So can I move the addition around? Can I change the order? Okay, and I did. All right, ready, guys? This is what I'm going to do next. What am I doing there? I'm using another property there. There's? Associative. How'd you get that? Grouping changed. Normally, in order of operations, when I add these two, then this one, then this one, then that one. But I'm not doing that. I'm going to add these two first, then those two first, and then if I can, combine them more. So how many properties have I used so far? 2. I actually used a third one, but I didn't change it for you guys. What happens if I do that? Good. Yes, what is it, Philip? Identity property. Guys, what's 1 times A? What's 1 times A? A. What's 1 times A? So do you have to have that 1? Look at that. Look at that. You could put that 1, you don't have to, but I'm going to put it, that's the identity property. That's saying 1 times A equals A. Is that okay? Is that identity? So how many properties have I used so far? 3. You think I'm done? No. I'm going to use one more, the ultimate one. Do you know what the ultimate one? Ooh, you guys said it. Now, can I just say something on the test? Some of you, remember that? I think everyone's taken almost. Okay. There was one problem that you could have worked out any way that's mathematically correct. But some of you chose the correct way, which is the easy way in my case. And I looked at it and said, whoa. They made this problem from very difficult to super easy because you use which property? Distributive property. How many of you think you use the distributive property and what I'm referring to in that test? Maybe you don't remember. I don't know. But, okay, some of you may think. Okay. So I was like, wait, the distributive property? That was on the test? I hope so. I hope you remember that. Okay. Here's the distributive property, and please listen to me carefully. I'm going to have you work these problems out today in a certain way, but then soon I'm going to make you do it the easier way. So don't think I'm always going to make you do this long process, but I do want you to understand how many properties have I used so far? 3. So please don't think, we just do stuff and you get it right and great. You use properties. Okay, here's 2a and here's 1a. What's going on between them? Addition. They're being added. Do you notice that these two have a common factor? What's the common factor between 2a and 1a? It's a, right? Ready? I'm going to take that a out, and then what goes in parentheses if I'm using the distributive property? 2 plus 1. I need you to confirm with me before I go further because if I just make stuff up, this is really bad. Is a times 2 plus 1 in this format, is it the same thing as what it originally was? Yes. So I did not change things. You know what? I'm just going to take away an a because I don't like them. No, you're using the distributive property. Okay, and then what would I have to do next here? Yeah, what's 2 plus 1? 3. Okay, so I get a times 3. Okay, and then I write 3a. Whoa. Stop right there, Drew. I said A times 3, not 3 times A. What property was being applied there? Yep. I did commutative property of, this time, multiplication. So how many properties have I used on this problem? 5. I used 4, and I used one of them twice, right? I used commutative property twice. And technically, one was addition, one was multiplication. So how many? 5 properties on one problem. And you think I'm done? No. Yes, I am done. Come on, guys. 5 is enough. Okay, let's do it here. Let's just do the distributive property one more time. How do you think you would write this using the distributive property? Can I tell you this, by the way? Mr. A, can't you just do 3 plus 2? That's 5C. You're done? That's impressive if you're a 4th grader. If you're a 7th grader, if you can show me the distributive property, a 4th grader is going to look at you and say, huh? Because this is higher level math. So who can give it to me? Give it to me in the distributive property. I know these 3, 4, no. 5, 6, Sophie, go ahead.
C times 3 plus 2.
That's it. What would I do next here, Matthew? What's that? All right. And is that how I write those numbers, Brad?
You do 5 times 5C.
Good. 5C. Awesome. What's going on between 3A and 5C? Addition, right? So I'll put that little sign. Do you see it? Do you see this? 3A is a term, correct?
Yes.
And 5C is a term, correct? Just trick questions here. Can I combine these two together?
No.
Okay, I see this and I see that, and it's not both. So which one is it? Is it this? I can combine them, or no, cannot combine them? Okay, is this a term? Yes. Is that a term? Yes. Are they like terms?
No.
Eva, she just did this. Why are they not like terms?
Because A and C are different.
Yeah, do these two terms have the same variables? No, they're not like terms. Can I combine them anymore? No, I'm done with that. But, do you guys see anything that's missing? Yeah, where'd this constant go? Poor constant. Oh. He's just there. He's still there. I don't just throw away 20 like, oh, 20's gone because it didn't have a variable. Let me tell you this here. The original expression is up here. You guys remember this is the original. Now look at the new. Is it truly simplified? Is it simpler? Look at that expression. Look at this expression. It is. Does that always mean it's like, just like I totally get it completely? No. But is it simpler than the first expression? The answer to that is yes. So how do you simplify expressions? You add or you combine like terms. That's how you do it. That's simplifying. Okay. Whew. This is hard to do, guys. Like terms is like draining on me. So let me give you a problem and see if you guys can figure it out.
Can we use the distributive property?
Yes, use the distributive property. And again, guys, I know there's a shortcut, but I need you guys to get what we're doing here with these problems. Okay, let me find you. Tough one or easy one?
Tough.
Oh, I like your attitude. Okay, here we go. I'll give you this.
Oh my gosh, Sam. Oh yeah.
Okay, I'll walk you through it. So if you want to go ahead of me, fine. But if you want to know what in the world's going on, I'll help you. Okay, this has how many terms? I need to figure out how many terms first. So yeah, show me with your fingers if you. So this many, or maybe, I don't know. Okay, so most of you have 3. What's the first term, Natalie?
13. Well, okay, sorry.
That's okay. The whole thing. What's the first term?
Oh, negative 13 RS.
The first term is negative 13 RS. That's it. What's the second term? William?
12S.
Negative 12S. And Andrew, what's the last term?
6 RS.
6RS. Do you guys notice anything? I'm really picky on stuff, but I did something kind of weird on the first and second term. What do you guys notice about my first and second term compared to that third term? Look what I underlined. I did something weird, maybe. Yep.
You
I agree.
underline the negative?
What? Negative? Why would I do such a thing? Okay, this is why I would do such a thing. Okay, some terms can be positive and some terms can be negative, right? So this one's a negative term. This one, though, Mr. A, I thought that's minus 12s. How many of you think it's minus 12s? It is minus 12s. That's what it says. But it's also negative 12s. But wait, I thought it's being subtracted. You're saying it's negative. Which one is it? Okay, ready, guys? Look, everyone needs to look on the board, and I think some of you get it. Look at the board. Watch the marker. Stay. Change. What's the opposite of 12s? Do you remember that? No? Yes? What did I say separated terms on that first problem? Oh, sorry. What separated on the first problem? Plus signs, right? Mr. A, I see the plus sign there, but I don't see it there. Is it there?
Yep.
Yes, it is there. So what's the first term? Negative 13RS. Second term? Negative 12S. And last term? 6RS. Okay. That's a little... yeah, I hope you guys get that, but let's do this exercise before we add like terms and all that. Okay, Hudson, what's the coefficient?
13.
More to that. Not just 13, negative 13, right? That's the number in front. What's the coefficient here, Michelle? Negative 12. Henry, what's the coefficient here?
6.
6. All right, you guys good on that? What are the literal coefficients, Hagen, right here? Literal coefficients. R and S. What are the literal coefficients, Sam, here?
Which one are you pointing? Okay. S.
S. Good. Sorry, I was pointing too close to that S. Drew, literal coefficients.
RS.
Okay, you guys get that? Are there any like terms? Are there any like terms?
Yes.
Okay. First, second, and third. Which ones are like then? So tell me first and second, first and third, second and third. Okay, I think I heard here first and third. You see how I'm linking them together? So that's another way to combine them. So there are many ways to show like terms in your work. Just use one of them so we know what you're doing. Okay. Ready? I'm going to use the commutative property. Is that the commutative property?
Yes.
What did I do? I changed the order of the what operation? Because it's either this one or it's that one. Of the addition. So it's the commutative property of addition. Do you guys remember how I made you put addition or multiplication? You know why I did that? Because sometimes it's addition and sometimes it's multiplication, and you have to distinguish. All right. Are these two the like terms?
Yes.
What are the common factors? Common factors. Gracie? RS. So what should I put in parentheses? Andrew? Negative 13 plus 6. Oh no, what's negative 13 plus 6? Good. Negative 7. RS. So how do I write that? You write it negative 7 RS. Now, time out. We had a strange person in our class who decides to do this. And I marked them. Okay, somebody tell me why I'm allowed to say this and that. They're both the same thing. Someone's weird. They just changed it. Yes, ma'am? Of?
Multiplication.
Very good. Commutative property of multiplication. I'm allowed to do that, guys. So don't be put up. Like, Mr. A, is it RS or SR? It's either one. Either one. Okay. Does this guy have a like term?
No.
So, does anything change with that last term? Okay, this is normally what I put my answer, but how do you write it in the final form? So you notice there's plus, negative. Can I change that to make it look a little bit simpler? Yes, William. Hudson. Okay, great question. Are these two like terms? Okay, I think I know what you're thinking. But look at these two terms, guys. Are these two like terms?
No.
Wait, they both have an S.
But they are.
But they both don't have the R. Like terms have the same variables with the same exponents. So do they both have an S? But do they both have an R? You cannot combine these anymore. Does that make sense, Hudson? But I'm glad you came up with that because some people are going to combine those. How do I rewrite this and make it simpler? Because the parenthesis, I don't like that. Alex.
Like maybe separate the 7 and the 7R into an S. So you could add the 7 and the 12S.
And remember, you can't separate those because then you're going to have multiplication here and addition there, and they don't cross through. That's all right. You guys are thinking. Jackson?
We use the change jumps.
Stay, change, opposite. So either one's going to be good. I rather add a -2. Either one's fine. Was this tough? Whoa. The responses are pretty
It's going to
good.
be like this from your homework.
Mm-hmm.
Would we have to simplify it on the test?
Either one of these is good. But yes, you do have to simplify by adding like terms. Yep. Okay. Oh, that's the same thing. Yes, we are going to do this one. All right. Here's what the first problems on your homework. So this is kind of review of the lesson, then I'll give you your homework. Okay. Number 2, this is actually on page 67 where it says try these. Someone turn there and tell me what the instructions say, because if you don't read the instructions, you don't know what's going on. Page 67. Who can read those instructions for try these on number 2? Lana?
Identify the number of terms in each expression.
Okay.
Name the numerical and literal coefficients and the constant of each expression.
Wait,
So how many things do I have to do? 4. You have to give me how many terms? What are the numerical coefficients? What are the literal coefficients? What are the constants, if any? Okay. What are the terms? Let's just start there. Okay, good. How many terms are there? 3. What are they, though? The first one is 4t cubed, or 4t to the third. Okay, so that first one's there. What's the second one? Swivel, you're getting this? That's my look. You guys get it? Andrew. It's -3r. What's the third term? Alex. -5. What? I thought those are subtraction. They are. But can you do stay, change, opposite? Yes. And really, some people even do this. They put little plus signs there to help them understand, but you don't have to. Okay. So how many terms? You're going to say 3. So that's one answer right there. 3 terms. All right. What are the numerical coefficients? So what are the numbers that are being multiplied in these terms? Okay. I'm going to go with Hagen. What are the numerical coefficients? 4, -3, and -5. Good. 4, -3, -5. Not just 3 and not just 5, but -3, -5. Okay. Yes, sir?
well, we have to show our hardest.
No. Just do that. So they'll give you this on your paper, and then this is what you write for your answer. But what are the literal coefficients now? What literal coefficients there is?
T to the third.
Good. T to the third
And then R.
and R. Okay, those are the literal coefficients. Okay? Are there any constants? And if so, what are they? Is it Hudson?
I have a question.
Oh, go ahead, go ahead.
Negative R, because negative, also negative 3, why would it be negative R?
Yeah, so if this is a -3, why wouldn't it be a -R? So here's what I'm going to do. See if you get it. What's -3 times positive R? Negative, right? If it were -3 times -R, what would be the sign outside? Positive. You see, one should be negative, one should be positive. the number is negative, the variable has to be positive in that case. So that's why it's just R. Good question. Okay, sorry, what's the...
Either one is right.
No, these three are the correct answers. That's what I need so far, but I need a fourth answer. What is the constant? Mary?
5 and then 5.
Negative 5 is the constant. All right. If you don't want to write words like this is the numerical, this is the literal, this is a constant, just give it to me in order like this. So first answer, second answer, third answer, fourth. Don't scatter all the answers and then I have to figure out what you're talking about. So does that make sense? First, how many terms are there? Then numerical, then literal, then constant. That's a lot to do. Do number 1. On page 67, try these, and then I'll give you your homework. Number 1. If you could do this, you're good. You're good to go. Did I pass out your test yesterday?
Yes.
Okay, you guys got them? All right. Yeah, because I still have to grade it. I'll have to grade it today. You didn't get it. Did you take it already?
I think so.
You were here on Thursday last week? Okay, yeah, I'll give it back. All right, it's time to ask you. I'm going to take some volunteers, and the volunteers are those who are looking at me. That's who I'm going to pick from. Yes, the people are like, not going to look at him. This is number 1. All right, first I want the number of terms. Who's looking at me? Matthew. How many terms? 3 terms. Jackson. What are the numerical coefficients on number 1? 3, 6, 1. That's correct. Josiah, what are the literal coefficients? Sorry, say that again. Just a little louder, Josiah. The fan's on. I'm sorry.
X squared.
Okay, x, y, and x squared, you said? Okay, that? I'm good with that. Technically, you could say x and y, but I'm good with all 3 of them because they're not the same value. One is x and one is x squared. And you can write that in different order. That's, yes, ma'am?
Y squared.
Oh, y squared, yes. You probably said it right, Josiah, but I didn't hear it. And is it y then?
I put an X, Y.
There's 2 X.
Yeah, so you just put x and y squared. I'm sorry. That's it.
No, wait, what did
I put
I
them
say?
together. I put X, Y squared, and then X.
There's
Oh, I see. Yeah. No. I got you. But how many different variables are there? There's just an x and there's a y squared. So you don't have to put another x.
If we did.
Or another xy. No, take it off if you did.
If we did xy squared without doing a comma in between.
No. There's only an x. Wow. There's only an x and there's a y squared. That's it. I know that there are 2 x's, but they're still separate. So just do it like that. Yeah, I count it wrong, but I'm hopefully helping you out. And then is there a constant?
1.
So you just put 1. There you go. Sorry about that. Did you guys get that? Okay. And again, if you have RS, is it the literal coefficients R and S? They're separate. So you don't just put them together like they're a new unit. All right, your homework. Whew. Mr. A has recanted on his original plan. 1 through 6, all. How'd you know that, Jack?
Wait, what?
I hope it wasn't from the other class.
Jackson told me.
Jackson, where'd you hear it from? Oh, that's not good for them.
Wait, you heard Thomas? Even
Oh, don't worry. We'll fix that problem. Okay, anyway, you do need to do 1 through 6 all. We're not even adding like terms tonight. Just get the coefficients numerical, literal, and constant. Just get that down. 1 through 6 all. Go ahead.
So you don't want us to like actually.
Sorry?
You